Now understand. So when we are doing, the reaction rates, just understand what topic it is. It is very simple topic. We have to discuss in this the collision theory. We have to discuss in this the collision theory. Okay. Now, what is collision theory? Understand. What is collision theory? Collision theory basically means that how does a reaction takes place? First of all, how does a reaction takes place? Right. So basically, the point is, what is responsible for the reaction to take place? So, for example, if you say N2 plus 3H2 gives me 2NH3, and this is basically my Haber's process. Yes or no? So, when this is my Haber's process, what would you mean by this?
Yes.
So, this is happening in the presence of nickel, this is happening in the presence of iron as a catalyst, and molybdenum promoter,
Right.
and a very high temperature and a pressure, and a moderate pressure of, let's suppose, 2 to 4 atmospheres pressure. So these are the conditions under which we sort of carry out this particular reaction, right? So
Yeah.
my point here is, when you are carrying out this reaction, Shruti, so what is exactly happening? Why do you need to apply this high temperature? Why do you need to apply this high pressure, right? So the point is
Yeah.
that, when we increase high temperature, when we increase the temperature, when we make the temperature really, really high, what exactly happens? Understand that, it increases the kinetic energy of the molecules. It increases the kinetic energy of the molecules. So it's like this, that, when we are talking about when we are talking about hydrogen and nitrogen combining, so obviously you would see that, ma'am, this reaction takes a certain amount of time to occur. It is not that, the product would be immediately formed. This reaction would take some amount of time to occur. So
Right.
why is it happening? Tell me. So there is a single bond between hydrogen and hydrogen. So we have this particular hydrogen, the black hydrogen, and we have the red hydrogen, right? So both of them are bringing their own electrons, and thereby there is a bond between them. So when I talk about the hydrogen molecule H2, definitely you see that there is a bond between the two hydrogen atoms. I suppose you're understanding, right?
Right. Yeah.
And also, when you talk about the nitrogen atom, so there are two nitrogen atoms also, like for example, black nitrogen atom and the blue nitrogen atom. Yes or no? So when
Yes.
I talk about the black nitrogen atom, I suppose you're understanding that there are one, two, and three, and we have one, two, and three, and four and five, because the nitrogen atom, this nitrogen atom, the blue one, okay, the blue nitrogen
Yeah.
atom will have what? Because the nitrogen's atomic number would be 7. So configuration would be 2, 5. Yes or no?
Right. Yes.
So when nitrogen's atomic number is 7, configuration is 2, 5. I hope you're understanding that there are 5 valence electrons here. So those 5 valence electrons we have drawn here. And similarly, I have also drawn the 5 valence electrons of nitrogen in the black color, which is this one.
Yeah.
And
Yes.
then they form a bond. So they form a bond something like this. So there is a triple bond between the two. Like for example, one black electron and one blue electron. So there's a single bond, then another black and another blue, and then another black and another blue. So we could see a
Yes.
triple bond here between the two nitrogen atoms. And this triple bond, Shruti, is a very, very strong triple bond. I hope you're understanding. It is a very strong triple bond. Yes or no?
Yes.
So now I hope you're understanding that nitrogen, because it has completed its octet, because its octet is complete, why do you think that it is going to react? Its octet is complete. Yes or no?
Yeah.
So when its octet is complete, I suppose you're understanding that it is not going to react at all. Because what is the driving force of an element or an atom to react? You tell me. The driving force of an element or an atom to react is that, its octet is incomplete. So that is why it wants to react further.
Yes.
But nitrogen exists exactly in the form of a molecule, and the molecule is stable.
Right.
Yes or no? So why would it react? So you understand that, to carry out a particular reaction, we heat and then we wait for the reaction to occur. Are you understanding?
Yes.
Then we wait for the reaction to occur. When we say that, we are waiting for the reaction to occur, I hope you're understanding that, the heat would try to break this bond. The heat would also try to break this hydrogen atoms molecules bond. So where is this time going? The time is going in breaking the previous bonds. You understand? The time is going in breaking the previous bonds, because if the previous bond don't break, then hydrogen will not become individual. Then hydrogen's
Right.
octet will not be, then hydrogen's duplet will not be complete. Are you understanding? So when
Yeah.
hydrogen's duplet will be complete, then why will it react? So we have to first unpair it. We have to first make it in a situation where it still wants to attack, where it still wants to combine with somebody else. So we have to break the bond. And that is why we have to provide a little bit of heat in the initial starting situations. Are you understanding?
Yes.
So thereby, what do we see? And then, when nitrogen becomes alone, because its octet is still not complete, because it has just come out of the molecule, so it would be still 2,5. It would still need 3 electrons. Are you understanding? And when
Yeah.
it would need such 3 electrons, I hope you're understanding that this would be now the whatever time would take to form the bond between hydrogens and nitrogen. So they would just hit with each other and they would form the bond. Are you understanding my point? So with this
Yes.
explanation, what are we understanding? We are understanding that whatever is the time taken for a reaction to occur, you know, whatever is the time taken for a reaction to occur,
Yeah.
okay, is basically being spent where? Is basically being spent to break the previous bonds, is to break the previous bonds and to form new bonds and to form new bonds. Are you understanding my point?
Yes, ma'am.
Okay, so that's one particular point. Now understand. So sometimes what exactly happens is that, the molecules are obviously moving. The molecules are
Yes.
consistently moving.
Yeah.
But when the molecules are consistently moving, what is happening? They want to collide with each other. Yes or no? They want to
Right.
collide with each other. So the point here is that, there is this molecule, the red molecules, let's suppose they represent the H2 molecule, H2 atom. Okay. So we have H2 atoms. We have H2 atoms here. And we have these N2 atoms here. So they are consistently moving, right? So they are moving here and there and here and there. But the point is, so this nitrogen atom would move here and here and here and here, and randomly it is moving. This hydrogen atom would also move randomly. But, when they're colliding, so their collision may be occurring at a very slow speed, right, Shruti? So with a
Yes.
slow speed, they would not be able to hit so strongly. Because see, it's important to understand. See, when two H and H and there is a bond between them, and another N and N, there is a triple bond between them. When they hit, you know, the H is moving towards N and the N is moving towards H. They
Yeah.
hit. So it's not easy for the atoms to come closer. I hope you are understanding, right?
Yeah.
Why it is not easy for the atoms to come closer to each other? Just see. So we have this nucleus and we also have this hydrogen atom. So I hope you're understanding that there is an electron density. There are electrons on the outside. Are you understanding? There are
Yes. Yeah.
electrons on the outside. So there is a lot of electron cloud here. There's a lot of electron cloud here. Yes or no?
Yeah.
And when another atom is also there, just besides, let's suppose this blue atom.
Yeah.
So we also have this particular nucleus. So there is this particular electron. Are you understanding?
Right.
And when this is happening, when the two atoms come closer to each other, don't you think that the electron clouds of both of these, because when they come closer, this comes here and this comes here, don't you think that the electron clouds would repel? You understand? The electron clouds
Yeah.
would repel. Yes or no?
Right.
And when the electron clouds would repel, I hope you're understanding that there would be a lot of repulsion. And because of this repulsion, the energy would increase. Do you understand? The energy would increase. Because obviously, when the molecules are colliding, the repulsion is there. And I have already told you that, when you do not want to do something that you want, you understand, when you do not want to do something and somebody is forcing you to do that, what exactly
Yeah.
happens with you? Tell me. Don't you really feel that, you get angry? So your anger is your potential energy. I suppose you're understanding. Right. So
Yeah.
what exactly do you think would happen? Tell me. That there would be a lot of increase in energy, and that repulsion, that increase in energy, Shruti, that energy would sort of lead to the breaking of the previous bonds. Because when the energy increases, the molecule, the system tries to reduce the energy. And how does it reduce the energy of the system? It absorbs back the energy, and that absorption back of the energy that the system has increased due to repulsion leads to the breaking of the previous bonds. Are you understanding my point?
Yeah.
So the point here is, Shruti, that when we have this particular structure, so the old bonds are breaking down. So you understand that there needs to be a tremendous increase in the energy. There needs to be a tremendous increase in the energy. Why so? Because if they collide very strongly, then they would come so fast with each other, towards each other. And when they
Yeah.
come so fast towards each other, what would that mean? Tell me. When they come towards each other so fast, then the increase in energy would be very, very high. You understand?
Yeah. Right.
Okay? Are you understanding? So that's the concept. That's the concept.
Okay.
Are you understanding? So I suppose you're understanding that, when the molecules come very slowly towards each other, so then the potential energy will not increase at a very fast rate. They're coming slowly towards each other, slowly towards each other. So then the potential energy will not increase, but they come immediately towards each other, immediately towards each other. Then the potential energy will increase, and then that increase in energy would lead to what? Would lead to the increase in the energy, so much so that
Ma'am,
it.
your voice is breaking off.
Oh, now is it better? Just a.
Hello.
Yeah, now is it better? Hello? Hello? Yeah, hi, Shruti.
Hello. Can you hear me?
Yeah, yeah, sure.
Okay. Yeah. Yeah. Your voice was just completely broken off. I couldn't hear you.
Okay, no worries. So I hope you're understanding what is happening right here, right? So there's a lot of increase in potential energy, which is why the previous bonds break. So
Right.
what is
Yeah.
important? What is important for the reaction to happen? Collision. If the collision doesn't take place at all, then no reaction can happen. And that should be a
Right.
very, very fast collision. That should be a very, very fast collision. And when
Yeah.
can that very fast collision occur? When the molecules or the atoms have a very, very high kinetic energy. Are you understand?
Yeah.
So that's the point. And why do we provide a lot of temperature, a good high amount of temperature to the atoms? So that their kinetic energy can increase.
Right.
Do you understand? So that is the concept. That is the concept. So now you understand that, when we are talking about the collision, so there are two important factors. First is the collision. Collision should be a very high energy collision. That's what I told you. The second
Right.
factor should be, it should be high energy collision. Second factor should be that the orientation, the orientation factor. Now, what is the orientation factor? That is important. The orientation factor. Now, what is the orientation factor? Just see. Orientation means that we have N2, N triple bond N, and we have H2, H single bond H. Yes or no?
Yes.
And now there are two ways. So this is method one. Method one would be what? That N and N would collide just the way I have written them, horizontally. So the molecules, they just move horizontally like this and they collide. So then what would
Right.
happen? What would happen that N triple bond N would be there and there would be collision between H and H. There would be a collision between N of one molecule and the H of another molecule. I hope you're understanding. So
Yeah.
This N of this entire molecule N2 will only collide with this H of this entire molecule H2. Yes or no? So
Right. Yes.
then only one atom of one molecule is colliding with the another atom of another molecule. So there would not be much repulsion. There would not be much repulsion because only single electron clouds tend to come closer, which is why the repulsions between them would be very, very less. Are you understanding?
Yeah.
But the other method would be what? For them to collide, the other method of collision would be like this, like N triple bond N. Don't you think it could collide with H single bond H in this orientation, in the vertical orientation? So if this entire molecule collides like this, so what do you think would happen? Just tell me. What do you think would happen? There would be a collision between this N, the top N, the green collision would take place, and the red
Yeah.
collision would also take place. So basically, there is an electron cloud collision of four atoms or two atoms. So one collision here and one collision here. Are you understanding?
Yes.
So
Right.
what would that mean? Tell me. What would that mean? That that it is going to collide and a lot of energy would be produced, which is why new bonds could be formed. Yes or no? New bonds could be formed. And the situation would look something like this. The previous bonds would start to break. So I would show those breaking bonds with a dotted line. Okay. And H and H I would show with a dotted line like this. Are you understanding? And N
Yeah.
and H would be formed. And N and H would be formed. Right, Shruti?
Right.
So this is called as a state where, it is an activation complex. It is an
Right.
activation complex or activated complex, I should so to say. This is an activated complex.
Yeah.
What do you mean by activated complex? Activated complex is a situation where the previous bonds are breaking but not have fully broken down. Okay, where the previous bonds are breaking but not have been broken down fully, and the new bonds are being formed. The new bonds are being formed but not have formed fully. But not have formed fully. Are you understanding?
Yeah.
So what would happen then? You tell me. What would happen then? The situation would be like this, you know. So this would be the situation, and then finally this would convert into products where you would have ammonia and all the previous bonds would break. So I would say that in the first orientation, no reaction would take place. But in the second orientation, the reaction would take place. So
Yeah.
basically, no matter how fast the collision was in case one, but still no products would be formed. Why? That the products would be formed when there is enough collision. So collision was taking at a very, very fast pace. Collision was taking place at a very, very fast pace, but the orientation was not proper. Do you understand? The
Right.
orientation was not proper. I hope you're understanding.
Yeah.
Okay, so that's the concept.
Okay.
Are you understanding? So in the second case, the collision was there. Why was the collision there? The collision was fast also, and there was a proper orientation also. That is why
Oh,
new bonds could be formed.
right. Okay.
Okay, so understand one thing. To carry out a particular reaction, there are two important factors according to collision theory. One would be your orientation factor, and one would be the orientation factor, and one would be the energy factor. And both the factors are responsible, both the factors are important. Are you understanding my point?
Yes.
Right? Now, the second point here would be that none of the factors you could neglect, basically. That is important. And these two form the collision theory. These two form the collision theory. All right? Right?
Yeah.
And that's the basic concept. So whatever time is being dissipated in the reaction is basically the time taken by the old bonds breaking and the new bonds being formed. Understood or
Okay.
not? Right?
Yeah.
Now, just understand. So now, how do we know that, what is the speed of the reaction? Okay, what is the speed of the reaction? How do I know that? How do I sort of tell you that, what is the speed of the reaction? So let's suppose we have A plus B, 2B gives me 3C plus 2E. Some reaction I have, something like that. And let us suppose initially when time t was equals to 0, because I go to the lab, I take a beaker, I mix A to it, I add B moles, like B reactant to that, and then I'm heating it, and then I'm waiting for the product to form. Are you understanding? I'm waiting for
Right.
the product to form. So
Yeah.
what do you think? What do you think exactly would happen? Just tell me. When we're talking about the speed of the reaction, A will combine with 2B to form 3C and 2E. And initially, let us suppose we have taken 100 molecules of A2 and 100 molecules of B2 to form 3 molecules of C and 2 molecules of E. Do you understand? So A2 combines with 2 molecules of B2 to give you 3 molecules of C and 2 molecules of E, or 2 atoms of E. So
Yeah.
this side would be my product and this side is my reactant. And the reactants, first of all, you have to understand that reactants with time, they keep on decreasing because they're getting consumed up. And the products are formed. But when initially the product was zero, the product was zero. Why? Because it is just time t equals to zero. You have just mixed in the reactants. Are you understanding? You have just mixed in the reactants and you're waiting for the products to be formed. Are you understanding? So what
Yeah.
do you have in here? We have A2 plus B2. So when we have A2 plus B2, understand? When we have A2 and B2, do you understand? So A2 and B2, they are still reacting to form the product. So I hope you're understanding that, as the clock ticks and the time passes by, let's suppose 5 seconds have passed away.
Yeah.
So after 5 seconds, what would happen, Shruti? After 5 seconds, what would happen? So let us suppose I say that, 20 molecules of A have been used up. Let us suppose. So how many of these molecules am I left with? I am left with 100 minus 20. I'm left with 100 minus 20. That means I am left with 80 molecules. Yes or no?
Right.
Now,
Yeah.
my equation tells me what? My equation tells me what? My equation says that, here, according to my equation, for one molecule of A2, I require two molecules of B2. Yes or no? For one molecule of
Yes.
A2, I would require two molecules of B2. Yes or no? So,
Right. Yeah.
20 molecules of A2 are getting consumed, 20 molecules are getting consumed. Yes or no?
Yes.
So, don't you think that for one molecule, according to my balanced equation, if for one molecule of A2, 2 molecules of B2 are getting consumed, 2 molecules of B2 are getting consumed. So, don't you think that for 20 molecules of A2 that is being consumed in reality, don't you think that when 2 times 20, that means 40 molecules of B2 would be consumed,
Right.
right? So, thereby, 40 molecules of B2 would be consumed. Okay. Then you tell me, like for example, if from one molecule of A2, we see that 3 molecules of C and 2 molecules of E are being formed. So
Yeah.
what would that mean? From one molecule of A2, three molecules of C2 are formed. So if 20 are getting consumed, that means they're all getting converted into product. They're all getting converted into product, isn't it? So don't you think for every
Right.
one molecule of A2 gives three molecules of C? So don't you think that 20 molecules of A2 gives 3 times 20? That means 60 molecules of C. Are you
Right.
understanding, sir?
Yeah.
So basically,
Yes.
as the time passes, I hope you're understanding that, as the time passes, yes or no, the product
Yeah.
is increasing. The product is increasing, and now I have 20, and I have 60 molecules of C and 40 molecules of E being formed. Because if one
Right.
molecule of A2 gives me two molecules of E, then 20 molecules of this would give me 40 molecules of E. Just double the ratio. Are you
Yeah.
understand? Okay? Are you understanding?
Yeah. Done.
So
Yeah.
what would that mean? That, as the time passes, the products are increasing, first of all. The products are increasing and the reactants are decreasing. And what is the rate of reaction? What is the rate of reaction? What is the rate of reaction? The rate of reaction means, or rate of the consumption, the rate of consumption or production of a reactant, would mean what, Shruti? That would be the final concentration minus the initial concentration over time. That whatever this change has taken place, in how much time do you think that this change has taken place? Are you understanding?
Right. Yeah.
Right, so rate of consumption or rate of production of a reactant would be equals to the final concentration minus the initial concentration over time. Yes or no?
Oh.
So in the previous example, just have a look here. What would happen, Shruti? So what is the initial concentration? Can you tell me? The initial constant, what is the final concentration that is left is 80. And what is the initial concentration of A2? That is 100.
Right.
Yes or no? So if, for example, if
Yeah.
I just keep, it says like this. So for example, I gave you this reaction. A2 plus 2B2 gives me 3C plus 2E. And I told you that, initially at time t equals to 0, I have taken 100 of this, 100 of this, then no products would have been formed. So E would be 0. E would be 0. Yes or no? And as
Yes.
5
Right.
seconds passed away, as 5 seconds passed away, I hope you're understanding that only 80 molecules are left. That means 20 molecules got consumed. And here, for every one, we get consumed 2. So therefore, 20, how many get consumed? 40 gets consumed. Are you understanding?
Yeah.
So how many are left? How many are left according to you? 60 are left. And here, with every one molecule of A, 3 are getting produced. So 60 are getting produced because 20 gets consumed. And
Right.
for
Right.
every one consumed, when every one molecule of A getting consumed, 2 molecules of E are getting produced. So that would mean that, we have 40 molecules of E getting produced. So now let's suppose we calculate the rate of production of A. So rate of
Yeah.
production of A would be what? Rate of production of A. Okay? Rate of production of A is what? Final concentration of A is what, Shruti? 80? 80? Yes or no? And
Yeah.
initial concentration was 100. And in how much time these molecules have decreased? In 5 seconds time. Are you understanding? In
Yes.
how much time these molecules are decreasing? In 5 seconds time. Are you understanding? So basically, we have what? We have 80 minus 100 over 5. And that would
Okay.
be minus 20 over 5. And the concentration is in moles per liter. The concentration is nothing but molarity. It is moles per liter. So 20 moles per liter, and the time is in seconds. So you solve this, you
Okay.
get 4. and your answer shall be -4 moles per liter, because seconds goes upside, so it becomes second inverse. Are you understanding, Shruti?
Correct. Yeah.
So it says the rate of production of A would be -4 moles per liter per second. And what is negative depicting here? Negative depicts that there is a decrease in the concentration with time. Do you understand?
Right.
That means every second, the number of molecules are decreasing. Yes or no?
Yes.
Hmm? Then it says the rate of, so this is not rate of production, this is rate of consumption of A. This is
Okay.
rate of consumption of A because A is getting consumed. Okay. Similarly,
Right.
rate of consumption of B, let's calculate that. Rate of consumption of B. So what would that be? Final concentration is 20 or 60. Initial concentration is 100 over time. Time is 5 seconds. So what would that be? -30 over 5. Unit would be moles per liter over seconds. So 5 times 6, it would become -6 moles per liter per second. So that is
Right.
the rate of consumption of B, Shruti. Are you understanding?
Yeah.
Similarly, if you want to calculate the rate of production of C, so what would that be? That would be the final concentration of C. The final concentration of C, isn't it? It would be
Yes.
60 minus initial was 0. Yes or no? Over
Yes.
time. Time was again 5 seconds because everything this has happened in 5 seconds. 100 is decreasing to 80, 100 is decreasing to 60 for B2, C is increasing from 0 to 60, E is also
Yeah.
increasing from 0 to 40. So this all thing is happening in terms of, so we have 60 over 5, so we have 5 times 1 and 5 times 2, so we have 12 moles per liter per second. Okay, so what do we have? We have the production rate as 12 moles per liter per second. Understood or not?
Yes. Understood.
Right? So that is the answer.
Yeah.
Right. So what exactly here do you think would happen? So why am I calculating these rates of production for you? To show it to you that for a particular reaction, individual reactants decrease at different speeds.
Right.
And individual products are produced at different speeds. So, for example, if you calculate the rate of production of E, the rate of production of E. So, what is that, Shruti? It is final minus initial. So, that would be 40 minus 0 over time. Time was again 5 seconds. So, it was 40 over 5. It was 8. So, again, the value would be 8 moles per liter per second. That means, every second, 4 molecules of A, 4 moles of A is getting consumed. Every second, 6 molecules of B is getting consumed because there is a minus sign here. But
Right.
every second, 12 molecules of C is getting produced, and every second, okay? Oh, I'm so sorry. It is 5 times 12. Yeah, correct. And it says, and every second, 8 molecules of E are getting produced.
Yeah.
So, what does that mean? I hope you're understanding. What does that mean? It means that, when you are traveling by a car, what do you exactly tell me, Shruti? A car has 4 wheels in it, isn't it? A
Yeah.
car has 4 wheels in it. So what do you do? Do you tell me the speed of individual wheels, or do you just tell me the speed of the vehicle? Tell me
Speak.
speed of the vehicle. Sometimes we have a vehicle where we have the front wheels to be shorter and the previous wheels to be bigger. So obviously the
Yes.
wheel speed would be different, but we are not concerned with the wheel speed. So
Right.
what do you think I should do to make all the speeds equal? Tell me. What should I do to make all the speeds equal? Tell me. So here we got the speed value here as 8. This was the speed of one wheel. This was the actually rate of production of E. This was the rate of consumption of A. This was the rate of consumption of B. Yes or no? Oh, it was 40. I'm so sorry. This was 40. 40 over 5. That would be 8. It would be
Oh,
40 over 5. So it would be 8. And this was the rate of production of C. What do I do to make them same? So what am I looking for? I am looking for one specific value of speed, which could be entirely predicted, which could entirely be, associated with one particular reaction. Do you understand my point?
yes.
Okay, that's my point. So I am not looking here for individual rates or individual products. Just now see, understand, what should I do? Do you think that I should multiply 8 with 2? This 4, I should do nothing with this? Do you think that I should multiply this 8 with 2 also? And this 12 with 3? So what would happen? Just tell me. Once I
I think we
multiply
get
this with 3, I get 4. I multiply, divide this with 2, I... यार बार बार बता, मेरी यूट्यूब की वीडियो जाती है ये। गंद मचा रखा बार बार
दीदी,
आपने।
घर में तो घूमेगा ना बंदा, थोड़ा सामान तो उठाएगा। बाथरूम में लिया करो बैठ के क्लास फिर आप।
बस तेरे
क्लास
अगली बार तेरी क्लास में
हाँ,
आऊंगी।
तो यहाँ पे घुसते चिक चिक क्यों करती हो आप? सामान तो निकालूंगा मैं अपना।
पहले लेके
सुबह तो
बैठ।
चौथी बार हो रहा है ये।
Right, Shruti?
yeah.
So I suppose you're understanding what I'm trying to tell you.
Yes.
Okay? So that's the basic point here. Right. Now just see. Now just see. What exactly is happening? So I don't want to associate, one particular value to a particular, to every individual reactant. I'm not interested in that. I am
Yeah.
interested in calculating a single value for the entire reaction. Are you understanding?
Yes.
Right? So how would that work? So for example, if I give you this example, A2 plus 2B2 gives me 3C plus 2E. Yes or no? So
Yes.
if I'm giving this particular reaction, just understand, if I'm given this particular reaction, then what do you think would happen? What do you think would happen? Tell me. So we took initially 100, isn't it? We
Yes.
took initially 100, and then 20 molecules got used up. We got 100 this, 20 got used up. So we were left with 80 of this. We were left with 60 of this. We were formed with 60 of this and 40 of this. Are you understanding?
Yeah.
And thereby you understand that in how much time? In 5 seconds time. So at t equals to 0, it was 100. At t equals to 5, it was 80. Yes or no?
Yes.
Right? So what was the rate we calculated? Do you think the rate that we calculated here was 4 moles per liter per second? For V, we calculated how much? We calculated 8 moles per liter per second. For C, we calculated 12 moles per liter per second. I hope you're writing it down. And for
Yes.
E, we calculated how much? For E, we calculated how much? Tell me.
We calculated 8.
8. So for E, we calculated 8.
Yeah.
Yes or no?
Yes.
So basically, now you see what is happening. But these are different values. I don't want these different values, Shruti. I want one single value for this entire reaction. Do you understand?
Right. Right.
So what do you think I should do? Don't you think that if I multiply 4, divide 4 with 1, divide 8 with 2, divide 12 with 3, and again divide 8 with 2, don't you think I get 4, 4, 4, and
Yep.
4?
Yeah.
And now this makes sense that, I can say the rate of this particular reaction, the rate of this reaction is what? The rate of this reaction is 4 moles per liter per second. Yes or no?
Yes.
Are you understanding?
Yeah.
So that means what, Shruti? Tell me. That what do you think it is here? Just see what is 1? 1 is the stoichiometric coefficient of A2. What is 2, Shruti, that I'm dividing 8 with? It is the stoichiometric coefficient of B2.
Right.
What is C? What is 3? It is the stoichiometric coefficient of C in the balanced chemical equation. And what is 2
Yeah.
here again? It is against the coefficient of E in the balanced chemical equation. Are you understanding my point?
Right.
Hmm? So what would that mean? That ma'am, rather than calculating. So what are we calculating? We are calculating A final minus A initial over time. This is what we are calculating, and we are calling it as either the rate of consumption or the rate of production. Yes or no?
Right.
So I hope you're understanding that can I call this as delta A? Delta means change in the concentration of A over time. So can I simply say that it is delta A over delta T? Because time has also changed from 0 to 5.
Yeah. Right.
Are you understanding? So going forward, I would not be doing this example by numerical point of view. I would say delta A over delta T is my rate of reaction. Or I would say it is my rate of consumption or rate of production of some reactant or some product. Are you understanding?
Okay. Yes.
You got the point? Hmm?
Yes, I did.
Okay. But now, if I say for this reaction, if I say 3A plus 2B gives me 6P plus 7Q. So if I write down, Shruti, delta A over delta T, if I say delta B over delta T, first of all, you tell me what will be the sign of delta A over delta T and delta B over delta T and delta P over delta T and delta Q over delta T. What would be the sign of this? Tell me.
Like the units?
The sign, the plus sign or the minus sign.
Oh, okay. Yeah, it would be minus sign.
Exactly, for A and B, because they're reactants, they're getting consumed. So their final
Yeah.
concentration would be less than the initial concentration. Yes or no?
Right.
And what
Right.
would happen to P? Their signs would be positive.
Yeah.
Okay. But there's a rule. The rule says, Shruti, that the rate of the reaction, the rates, no matter what kind of rate are you talking about. Are you talking about the rate of reaction? Are you talking about the rate of consumption? Are you talking about the rate of production, like production? No matter what rate are you talking about. Okay. The
Yeah.
rate is always positive. You have to always take the rate as positive. But ma'am,
Right.
what do I do if it is coming out to be negative? How do you make a negative 3 positive, Shruti? By putting a minus sign just in front of it and it becomes plus 3, isn't it?
Yes.
So if delta A over delta T comes out to be negative, don't you think that you should apply a negative sign right in front of it?
Yeah.
So we apply this negative sign right in front of delta and delta B because these values individually would be negative. These
Okay.
values individually would be negative, and to make them positive, I need to apply a negative sign. Right? Also, do you think that they would be equal? Delta A over delta T, delta B over delta T, delta P over delta T, and delta Q over delta T. Do you think they would be equal, Shruti? Individually, do you think they would be equal?
No.
No. But how can I make them equal? How can I make them equal? Don't you think that I should divide them with 1 over 3? Because
Yeah.
the 3 is the
Right.
coefficient of A. Don't you think that I
Right.
should divide delta B over delta T with half?
Yes.
And don't you think that I should divide delta P over delta T with 6 and delta Q over delta T with 7? Then I can say that, they're all equal now.
Right.
Do you understand? Then I can say that they're all equal now. Yes or no, Shruti?
Yeah.
Right. So now, whenever I get to see a certain reaction, and this would be my rate of reaction. Are you understand?
Yes.
So the key points here would be the unit of the rate of consumption or the rate of production or the rate of reaction would be what, Shruti? Unit of the rate would be moles per liter per second, because that is nothing but the change in concentration over time. Change in concentration over time. Are you understanding?
Yeah.
So if it is change in concentration over time, the concentration change would be final minus concentration A final minus A initial over time. Yes or no?
Yes.
Right? So this is how we sort of calculate this. Understood or not?
Yeah.
Okay. So this is the concept. Second thing that you have to understand, that for the reactants, we always put a negative sign here. And for the products, we don't put any sign because they're already positive.
Okay.
Okay. What do
Okay.
you call simply, if I ask you, what is the name for delta A over delta T? You will say, ma'am, delta A over delta T would be called as the rate of consumption of A. The rate
Okay.
of consumption of A. Are you understanding?
Yes.
What would be delta B by delta T? This would be called as the rate of consumption of B. Delta P
Right.
by delta T would be called as the rate of production of P, and delta Q by delta T would be called as the rate of production of Q. Okay, but if you call 1 over 7 delta Q by delta T, then that would be called as the rate of reaction.
Okay.
All right, now just have a
Yeah.
look at the question. How does it work? The question would say like this. The question says, the question says, in a reaction, in a reaction, 2A gives me 5B. Reactant A, reactant A changes from 10 molar to 2 molar in 3 seconds. Calculate. Number 1, the rate of consumption of A. Second, it says calculate the rate of production of B. Third, it says calculate the rate of reaction. Yes or no?
Right.
So for this particular reaction, Shruti, what do you think you can do? Could you write down 2A gives me 5B? Do you think that you can write down rate of consumption of A would be what? dA by dt and dB by dt. dB by dt would mean, I should say delta A over delta T. Sorry. Delta A over delta T and delta B over delta T. And you know that they're not equal, but if I divide it with 5, then they become equal.
Right.
And I should put a minus sign with the reactant side also, because it would be negative. Because delta
Right.
A was negative. So in order to make that negative positive, I have applied a negative sign here, so that the
Yeah.
entire rate becomes positive. And this is called as my rate of reaction. Small r indicates what? Rate of reaction. Yes or no?
Yes.
But the information in the question has been given that the A changes from 10 molar to 2 molar. So for me,
Yeah.
delta A would be what, Shruti? A final minus A initial over change in time. That means T final minus T initial. So what is A final? 2 molar
Right.
minus 10 molar. Over time was When time has passed and now the time is 3 seconds, initially definitely the time would have been 0 seconds. So 3 minus
Yeah.
0. So it would be what? Minus 8 over 3, and I should have put a minus sign out of it because I do not want the consumption rate should be negative. So my rate would be 8 over 3 molar per second. What is molar? Molar means, Shruti, 8 moles per liter over 3 seconds. So my final answer of the rate of consumption of A, that means my delta A over delta T. My delta A over delta T would have been 8 over 3 moles per liter per second. Right, Shruti?
Right. Yeah.
So can I just put it here? Can I just put this value here in this particular equation? Tell me.
Yeah. We can do that.
And with that, can I not calculate delta B over delta T? Tell me.
Yes.
So it would be minus half delta A over delta T. I have just found out to be 8 over 3. So I'm putting that here equals to 1 over 5, and I can just find out delta B over delta T, which is my second part. It says find the rate of production of B.
Right. Yeah.
So this 5 goes here and it becomes minus 40. Minus 40 over 6 would be delta B by delta T.
Right.
Understood?
Yeah.
Okay. So that is the concept.
Okay.
Yes or no?
Yes.
Right?
Got it.
Right. So that's how it would be.
Okay.
Right, Shruti? And when it says calculate the rate of reaction, then what is the value? You have delta A by delta T, Shruti. 8 over 3.
Yes.
So just you have this, see, understand. This is the rate of reaction. This R is equal to this and this. So they're all
Okay.
equal. Do you understand? They're all equal.
Right.
So when they're all equal, Shruti, what would happen? Just tell me. When they're all equal, what would happen? So just to find out R, what do you think I should do? I have written 1 over 2 delta A by delta T with a minus sign would be 1 over 5 delta B by delta T is my rate of reaction. So all these three are equal, isn't it?
Yes.
And when these three are equal, Shruti, and I have just calculated delta A over delta T, what is that? 8 over 3. So if you understand that, I would do minus 1 by 2 into 8 over 3 would be my R. So my rate of reaction would be what, Shruti? 8 over 6. Or I could say 2
Right.
times 4. So my answer here would be 4 over 3 moles per liter per second. That would be my rate of reaction. So all the values I have calculated just by my rate of reaction. Understood or not?
Yes. Yeah.
Right? So for a given reaction, so it doesn't matter what reaction are you given. Like for example, if I give you 3C plus 9D gives me E plus 6F. So
Yes.
just by looking at the reaction, my first instinct would be what? To write down like this: minus 1 by 3 delta C by delta T would be equals to minus 1 over 9 delta D by delta T would be equals to 1 over 1 delta E over delta T would be equals to 1 by 6 delta F over delta T. Are you understanding?
Right. Yeah.
I need to have this. I need to have this. Are you understanding?
Yeah.
Any doubts in this?
No,
Okay,
ma'am.
sure.
Yes.
So that is how I sort of need to solve it. Understood or not?
Yeah.
Yeah, right. Understood.
Yes.
So I think that's it for today. So I have covered a majority part of it, and next class we will be doing certain more different types of questions. We would be talking about law of mass action, rate law. Okay. So,
Yeah.
but for today, I suppose these kind of numericals you will be able to tackle. So we'll be doing some more numericals. You will understand, right, Shruti?
Okay.
All right. So
Yeah.
that's it for today. Thank you so much. Can you
Okay, ma'am.
please
Yeah.
call others?
Yeah.
All right.
Yeah. I will.
Thank you. Thank you.